This is determining whether a relationship is linear. So this is page 243 on the new book. Notice it's not the like M2-55 or whatever it was before, because there wasn't anything in the old or any of my old videos or videos from the old book that matched up. So I'm making a new video. So here we go. So you previously used similar right triangles to show that your slope is the same between any 2 points. The converse is also true. If the slope between every ordered pair in a table is constant, then the ordered pair will form a straight line. So we're going to determine if this is linear or not. So if we're going to do A in red, we'll do B in green. That almost looks like it's black, and then we'll do C in black. Okay, so if we're going to do A, and we're going to do it between the point 413 and 928. So we're going to determine the change between those two. So again, just like we did in the last video that you watched, you're going to take the second number and subtract the first. So I'm going to do 9 minus 4, which is 5. And then we're going to do 28 minus 13. 28 minus 13, which is 15. Okay, and then we're going to write that right here. Remember, it's always change of y, so 15 divided by 5. 15 divided by 5 is 3. Okay, so that's the rate of change between those 2 points. Now we're going to do 928, so this point, and 1134. So we're going to do those 2 points. Okay, again, take the second number, so 11 minus 9 is 2. 34 minus 28 is 6. Set it up, change of y over change of x. So 6 divided by 2 is 3. Okay, now let's do the last point. So if we do it between the point 1134 and 1647. So again, take the second number, 16 minus 11 is 5. And then we're going to do 47 minus 34 is 13. So then we're going to write that as the change of y, 13, over the change of x, which is 5. 13 divided by 5 is 2.6. What would that have had to be? I want you to think about this. What would that have had to be in order for it to be the same of 3? Well, this would have had to be 15 divided by 5, so this would have needed to be 2 larger, so 47, 48, 49. So 49 would have had to be that number in order for it to be the same. So notice this change right here. The fact that this rate of change or slope is not the same means that this is not linear. If you were thinking about a graph, you'd have 2 points that look like this, and then another point, actually it wouldn't be higher, it would be lower. So it would be a straight line here, and then all of a sudden it changes. So notice it's not linear because it would be not constant. So it does not represent a linear relationship because the values do not have a constant rate or slope in that case. Okay, I'm just going to add to the last set of notes that I was writing. So to determine if a table is linear, the points have to be constant. Okay, my pen was running out. Sorry, you can hear a plane flying over right now. So let's do these tables over here. let's look between 25 and 34. Let's find that. So 34 minus 25 is 9. 45 minus 34 is 11. 52 minus 45 is 7. 61 minus 52 is 9. Okay, and then we're going to do it on this side. 1 to 2 is a change of 1, 2 to 3 is a change of 1, 3 to 4 is a change of 1, 4 to 5 is also a change of 1. So when you look at those, 9 divided by 1 equals 1, 11 divided by 1 equals 11, 7 divided by 1 equals 7, and 9 divided by 1 equals 9. So are these changing by a constant amount? No. So it is not linear. Now, I do want to point something out from the video that we did last time. So on this one, remember when we did 3, 6, 12, but this side was also changing, 4, 8, 16. So when we divided them, 3 divided by 4, 6 divided by 8, 12 divided by 16, each of them were 0.75. This one is linear because even though we skipped a point here, even though we skipped that point, when you divide the change of the y by the change of the x, you still get the same cost per ride. So this is linear. This one is not linear, and you can see one side is changing and one side is not changing. So that would make it not linear. Okay, sorry, I'm turning to the next page in my book. Okay, so let's look at this one. 12 to 8. 12, or 8 minus 12, that's going to be a negative because it's getting smaller. So you're going to do 8 minus 12 is negative 4. 4 minus 8 is negative 4. 0 minus 4 is negative 4. Negative 4 minus 0 would be negative 4 as well. Okay, this side is staying the same. So you don't necessarily have to write all of these out to check, because if these are all the same value and these are all the same value, every time you divide it, it's going to be negative 4 divided by 1, which every time you divide that, you're going to get negative 4. So this one is linear. Okay, let's flip to the back of this page. This is, we already did that part the other day, but, oops, I flipped too much. Oh no, where did it go? So just so you know, these are called first differences. So let's write that in our book. Sorry, that was on page 244. I thought I had to flip the page, but I don't. It was right over here on this side. So these are called first differences. First, oops, that pen does not work very well. Let's do this one. First differences is when you subtract the change of y and the change of x. Okay, so these are just called first differences. I can't remember if we ever wrote that definition or not, but first differences is just when you find the difference between these numbers, really when you find the change of y and you find the change of x. And we use those to determine if something is linear or not linear. Okay, that's the end of this video.